All right. This video is going to run through a sample problem of uh, determining a solution concentration with an acid-base titration. Okay, so it's practice exercise 4.17 on page 153 in your book. As usual, I've got this is the whole problem here, but um, just so you know where to find it if you need to. All right, so it doesn't look too complicated, right? Like, what is the molarity of an NaOH solution if 48.0 milliliters is needed to neutralize 35.0 milliliters of 0.144 molar H2SO4? All right. So the first thing that we need to realize is we're talking molarity, right? So since we're talking molarity, we're talking, remember, molarity is moles over liters, right? So that means in order to get the molarity of NaOH, okay, what do we need? So I'm gonna do this in sort of like different colors here. So to find, so we're looking for the molarity of NaOH. Right? So to find the molarity of NaOH, we need the moles of NaOH which we don't have, and we need liters of NaOH. Okay, well, we're told here, right, that we have 48 milliliters. So the liters of NaOH, if we turn from milliliters to liters, move the decimal 3 to the left, so we get 0.0480 liters. So we have liters of NaOH, correct? Okay. We need to find moles of NaOH in order to find the molarity. So how do we do that? Well, we have, what else do we have here? We're told we've got the milliliters and the molarity of H2SO4, right? So what we're going to need to do here is, let's see, let's try this. We need to make a balanced equation so we can convert from the information we have from the H2SO4 into the NaOH. All right, so I'm going to do a balanced equation. We have NaOH plus we have H2SO4. Okay, and this is going to form, let's see, sodium sulfate, so it'd be Na2SO4. Let me check my solubility. It should be aqueous, and it is. Okay, plus we've got hydrogen and hydroxide, so that's going to be water. H2O liquid. Okay. So balancing, we would need, let's see, 2 here and a 2 in front of the water. And we're balanced. Okay. So that's our balanced equation. Now, we're going to use this sort of the same way that we were doing the last practice problem, the quantity of a solute by titration, because that's what we're really looking for. We're looking for the quantity of a solute here. So we can then plug it into this, right? So what I'm going to do to solve for this is I'm going to start with my 35 milliliters of the H2SO4. And again, you can convert it into liters in your head if you want. I'm just going to write it so people don't, so if people look back on this later, they know. So I'm writing this in red because this is what I'm going to do to solve for the moles here. So I'm going to go milliliters to liters. Okay, then I'm going to go, now I'm using my molarity as a mole over liter conversion. So and this is of the H2SO4. Okay. I'm not going to write the H2SO4 on the liters in the bottom there, but you can get the idea. Okay. Now I'm in moles of H2SO4. I need moles of NaOH, right? So I'm going to go moles of H2SO4. So in front of the H2SO4, there's nothing, so it's a 1. And I'm going to turn that into moles of NaOH. In front of the NaOH is a 2. Okay. All right. And I'm in moles of NaOH, which is what I'm trying to find here, so I can solve for that. So I get 0. Let's see, 3 significant figures, so 0.101 moles NaOH. All right, so up here, all right. Now, all we need to get our moles of NaOH, I'm sorry, not our moles, our molarity, is we're just going to take the moles of NaOH divided by the liters of NaOH and this will give us the molarity. Okay, so moles of NaOH liters of NaOH This gives us 3 significant figures, so 0.210 molar NaOH. And that's your answer. So it's really kind of putting two ideas together. It's not too hard once you break it down, but you just got to be organized and figure out what you're starting with and how you move through it to get the information you need to solve for your answer. Okay, great. If you guys have any questions, let me know.